In this video, I will talk about the polar coordinates. The polar coordinates is a prerequisite knowledge for the complex numbers. Okay, what is the polar coordinates? Now, polar coordinates are the means of specifying position in the plane by magnitude and direction. Before polar coordinates, what you learned is called Cartesian coordinates, also called rectangular coordinates. Okay, so the one with x coordinate and y coordinate is called rectangular coordinates. Okay, the other name is Cartesian coordinates. So you have the x value, and then we have the y value. And then the polar coordinates, in fact, is to measure the distance from the point to the origin and also the angle. Okay, so this is polar coordinates. Okay, so polar coordinates use concentric angles to represent the point in the form of r theta, where r is the radius, the distance from the origin. Theta is the angle from the positive x-axis. Okay, so for example, you can see this one is a 5,2, right? So we use the distance from the origin to this point. Okay, so this is r. And then we use the angle from the positive side of x-axis. This is the angle. So instead of 5,2, we use r theta. Now that is polar coordinates. Now, as you know, the theta can be any value, because if I go 360 degrees, then it still represents the same angle, right? It can be theta, it can be theta plus 360 degrees, theta minus 360 degrees. So to avoid too many different expressions, usually we'll restrict the range of angles in between 0 and 360 degrees, or negative 180 to positive 180 degrees. Okay, or the equivalent radian measure. Okay, so it's either 0 to 360 degrees. Yeah, so theta is either 0 to 360 degrees, it's minus 180 to 180 degrees. Okay, and if I change to radian, is either 0 to pi or pi to positive pi. Okay, now as you can see, minus pi and pi both refer to the negative side of x-axis, right? If I go this way, it is pi. If I go this way, pi. Okay, equal sign this side. Okay, so if it's on the negative axis, then we just say it's a pi. Okay, we don't say it's negative pi. Because they refer to the position. Just in case, if you don't remember how to convert the degree to radian, you just need to multiply by pi over 180. From radian to degree, you times 180 over pi. Yeah, later we'll see how to do this. Okay, now, for example, if you look at the point E, from the origin, the distance is 1, 2, 3. So that's why the radius is equal to 3. And then the angle is 30 degrees. Okay, now how do I know it's 30 degrees? Because this is 90 degrees. And then it has been divided into 3 equal angles. That's why it is 30 degrees each. Okay, 90 divided by 3, 30 degrees each. So that's why for this point, E is radius is 3, degree 30. Now, if I want to change to radian, 30 degree multiplied by pi over 180 degree, 180 divided by 30 is 6. So that's why it's 3 power 6. For the other one, the point F, okay, let's look at the distance. 1, 2, 3, 4. That's why the radius is equal to 4. And then for this one is 30 degrees plus 90 degrees together is 120 degrees. Okay, so if I want to convert this to the radian, 120 times pi over 180. So it's 2 pi over 3. Okay, next one. For point G. For point G, the radius is 2. Okay, when you come to the angle, right? If I go this side, is minus 150 degrees. Because this part is 90 degrees. This is 30 degrees. This is 30 degrees. So 90 plus 30 plus clockwise, so it's negative. So it's negative 150 degrees. If I choose to go the positive side, that should be 210 degrees. Okay, both are correct. It all depends on what the question requests. Now, if the question mentioned angle is in between minus 180 to 180, then theta should be negative 150. If the theta is 0 to 360, then theta should be 210 in this case. So if I change to the radian form, for 210, it should be 210 over 180 is 7 over 6. Yeah, so 7 over 6 pi. If it's negative 150, it should be negative 5 over 6 pi. Okay, finally, for H. By the way, when you watch this video, what you can do is, if at a certain point, you need some time to think about, you may just pause the video for a moment. Okay, for example, I'm doing the H. You may pause the video, try to work out by yourself. Okay, after that, you watch the video. Okay, then you see whether your attempt, your working is right or wrong. Now come to the H. 1, 2, 3, 4. The radius is 4. And then the H is kind of, you see, this angle is kind of, this line is equally divided at 90 degrees. So it must be 45 degrees, right? This is minus 45 degrees or 315 degrees. Okay, if you need to write in radian, minus pi over 4, or the other one is 7 pi over 4. Now, once again, it all depends. If the question use radian, then you should use radian. If the question use degree, then you should use degree. How do we convert coordinates in between rectangular, which is Cartesian? Okay, how do we convert Cartesian to polar or polar to Cartesian? Now, firstly, you may realize, it's just now when I show this one, this R is the hypotenuse of this right angle triangle. This side is equal to 2, the y coordinate. This side is equal to 5, the x coordinate. So the radius should be 2 squared plus 5 squared. Okay, or usually we write as x first. So it's 5 squared plus 2 squared. That's why the radius is always equal to the square root of x squared plus y squared. And then when it comes to the theta, okay, we could use sine, cosine, or tangent. Okay, for example, if I use tangent theta, that should be 2/5, which is y/x. Therefore, the angle is tangent inverse y/x. This is how we get from rectangular to polar. Now, if I want to go from polar to rectangular, we just use the trigo ratio because radius, x and y, and theta. So this x is the opposite, this y is the adjacent. So opposite over hypotenuse. I put wrongly, sorry. This is y, this is x. Okay, so opposite over hypotenuse. That is sine theta, right? So the y is r sine theta. And then opposite. Okay, and the other one is adjacent over hypotenuse is x over r. Adjacent over hypotenuse, x over r. That is cosine theta. So x equals r cosine theta. Okay, so here are the main concepts about how do we find the polar coordinates and how do we convert Cartesian to polar and polar to Cartesian. Okay, now let's look at some questions. Okay, if I have polar coordinates of 3, 1, how do we have Cartesian coordinates, √3 and 1, how do we convert to polar coordinates? So for this one, r is square root of √3 squared plus 1 squared. Radius is 2. The theta is tangent inverse y over x. Okay, you can write like this, but you should know it's a pi/6 special angle. So that's why for this one, it should be 2 pi/6. Okay, and if you need to label that, okay, you can use compass to draw a circle with a radius of 2, and then you find the angle that is pi/6, 30 degrees, and this is the point. Okay. Now, come to the second one. For part B, 3√3/2. If I square it, should be 9 times 3/4 plus the other one, negative √3 times 3/2. If you square, it's also 9 times 3/4. Negative squared become positive. 27/4 plus 27/4, that is 54/4. So it's 27/2. Okay. And then this one, okay, so r is √27/2. Okay, now let's look at tangent theta. Tangent theta tend to be -1. Okay, now this one, be careful. If you use your calculator, right, you will get theta is -45 degrees. Okay, and then just double check. X is positive, Y is negative. It must be in the fourth quadrant. That's why theta is -45 degrees. That is right. And then the length should be √27/2. Let's check. Yeah, √27/2, which is 3√6/2. Okay. Now, why I say that? Because in some other question, you may get it wrong if you don't know the quadrant. For example, part D. For this one, tangent theta is this. So you may think, oh, theta is 30 degrees. But it's really 30 degrees? No. X and Y are negative. So this one should be 30 plus 180. That's why for this one, theta is 210 degrees. Okay. So although tangent theta, tangent inverse theta can give us the angle, but you still better, in fact, you still must know where the point is, which quadrant, so you will get the correct angle. For part C, this one, you also have a problem if you calculate tangent theta. 2 divided by 0 is undefined. Okay, then you just draw the graph and see where the 2 is. The 2 is, 0, 2, the point is on the y-axis. That's why if you look at the angle, theta is 90 degrees. No wonder you cannot use tangent, because tangent 90 degrees is undefined. Okay, so just take note when you need to determine the angle size, it could be more challenging. Okay, some of you may have problem with the question 7 and 8. Okay, so if you haven't done the question 7 and 8, I suggest you pause the video and try first. Okay, after you try, you can have a look. If you find out you don't know how to work out this, okay, let's do it together. Question 7. Convert the following polar equation into Cartesian form. A, r equals 5. As you know, r equals the root of x squared plus y squared. So this is x squared plus y squared equals 5. Okay, here we are. Okay. Second one, r is 2 cosine theta. R is x squared plus y squared square root. Cosine theta should be x over r, which is x over the root of x squared plus y squared. Now this one I can even make it easier because if I multiply the whole thing by the root x squared plus y squared, I should get x squared plus y squared equals 2x. Yeah, that's how you get the answer. Next one, r equals 4 over cosine theta. Root x squared plus y squared equals 4 over cosine theta is x over the r. Okay. Wow. For this one, Okay, then the 4 should be equal to this times the denominator. Then I just get 4 equals x. So this one just x equals 4. Yeah. Okay, so this is how to work out the C. Yeah? So we just use the definition for R and cosine theta. Okay, next one. Convert the following Cartesian equation into the polar form. Since R equals the root of x squared plus y squared, R squared is equal to x squared plus y squared. So the first one, R squared equals 16. That's it. For second one, x squared plus y minus 1 squared equals 1. How do we convert this into the polar form? Okay, now let's try out. Because we know x equals r cosine theta, y equals r sin theta. Then we have to do like x squared becomes r squared. Okay, this is 8b. R squared cosine square theta plus r sin theta minus 1 squared equals 1. Okay, let's see whether we can simplify this or not. So we just expand them. Okay, so r squared times cosine squared plus sine squared. You should know the triple identity. So it's cosine squared plus sine squared equals 1. And then plus 1 equals 1, all gone. Now, because usually r is not equal to 0, so if I cancel the r is equal to 2 sin theta. Okay, I cancel the r, so you got r minus 2 sin theta equals 0, so r equals 2 sin theta. That's the equation for 8b. Okay, once again, if you feel that I explained too fast, you can always pause the video, see what I write, and then if you understand, then you continue to watch the video. Okay, the last one is very straightforward. Y replaced by r sin theta, x replaced by r cosine theta. Then we change the Cartesian into polar. Okay, so these are the necessary prerequisites we need to know about the polar coordinates, which is for the next topic, the main topic, complex numbers. Okay, thank you.